All right, good morning. The adventure continues. So, I am now going to look at the course PDF that I accessed yesterday for this trigonometry and precalculus course here at Western Governor University. Okay, Western Governors University. Here's my instructor, Ella Gorgon. I think would be how to pronounce your name, probably. Um, hmm. I wonder if she's on YouTube at all. Or uh, the office hours. I wonder if she has videos posted here. Well, we'll find those things out, right? I don't know. Yesterday was ground zero. Um, so I will just go over here to this PDF of the course, which kind of seems like a giant syllabus, but let's see. All right, so this course requires a performance assessment and an objective exam. It covers 6 competencies and represents 2 competency units. Okay, so the 2 competency units are my 2 graduate credits, my 2 CUs. All right, so it represents 6 competencies within those units. So let's see what I need to get competent in, showing mastery over. So trigonometry and precalculus covers the knowledge and skills necessary to apply trigonometry, complex numbers, systems of equations. I love systems of equations, vectors and matrices, sequence and series, and to use appropriate technology to model and solve real-life problems. Okay, topics include degrees, radians and arcs, reference angles and right triangle trigonometry, trigonometric functions and their inverses, trigonometric, that's the word from yesterday, trigonometric functions and their inverses, trigonometric equations, trigonometric identities, geometric, rectangular, and polar approaches to complex numbers, DeMoivres Theorem. How do you pronounce? Make sure I pronounce that name correctly here. Okay, pronounce this. Sorry. Oh. Oh, I can't listen to that. Why? Why do we need to use that voice? Don't we have better computer voices these days? DeMoivre's theorem. Okay. Um, but what does it say? And it could be 2 words instead of 1. Raising a complex number to a power. Oh, okay. So that's what it's about. It's about raising a complex number to a power. Got a picture here. And then we're going to raise it to a power. Oh, exciting. Exciting stuff. Okay, that looks very complex. Okay. And there's a theorem for that. All right, DeMoivre's theorem. Well, that makes sense that there would be some kind of theorem for that, since if you are raising a complex number to a power and it includes, the imaginary number, which is the square root of -1, that, we save ourselves from that when we have even powers in some senses, but it gets more complicated depending on how many terms you have in your polynomial. But yeah, okay, DeMoivre's theorem. Move. It's kind of like the word move is in Moivre, of movement. of movement of these complex numbers. Okay. DeMoivres Theorem. Systems of linear equations and matrix vector equations. Systems of nonlinear equations. Systems of inequalities. And geometric sequences, arithmetic. Arithmetic and geometric sequences and series. Arithmetic and geometric. Arithmetic and geometric sequences and series. Okay, college algebra is a prerequisite for this course. All right. Getting started. Welcome to Trigonometry and Precalculus. To master the competencies for this course, you will all right. So here are notes. Moivres Theorem involved raising complex numbers to power. Okay, out there. Now, to master the competencies for this course, you will either read the e-text or watch a video about a topic in precalculus. You will check your understanding by taking a diagnostic from the interactive homework and test, quizzes and tests portion of your e-text. When you do a diagnostic, you can practice what you got wrong by going to review results. You can also do the homework exercises, which are the full pool of items that the diagnostic questions are drawn from. Oh, that's good to know. All right, so homework. So basically, this is the deal. All test questions are repeats of the homework questions. So if you really want to get 100% on the test, it might behoove me to do all of the homework questions, huh? Okay, good to know. Okay, so when you do a diagnostic, you can practice what you got wrong, though. Okay, while you do homework or use review results, you will be able to access the relevant readings from the online textbook. You do homework or use review results. Okay. You will demonstrate your competency by successfully completing a project about modeling real world with these functions and passing a comprehensive objective exam. All right. The project probably isn't like timed in Proctor, but the comprehensive exam is. So that's kind of a difference there. Let me make a note of that. Question for later. Am I correct in assuming the project isn't timed and proctored but the am, of course, is okay. All right. Now, sinusoidal functions. I want to make sure I'm pronouncing sinusoidal correctly. But assume it says sine because of sine, cosine, and tangent. So pronounce sinusoidal functions. Sinusoidal, huh? Sinusoidal. No, I'm not gonna advertisement before I learn pronunciation of a word. Get that. Okay. Um, sinusoidal. So yes, it's sine. Sinusoidal functions. And passing a comprehensive exam. All right. Teaching dispositions statement. Please review the statement of teaching dispositions. Okay. Fine. Be professional. All right. All right. Now, competencies and objectives. This course covers the following competencies. Trigonometry of angles. Aha, so these are the 6 competencies. All right. We are working on mastering 6 competencies. All right. Trigonometry of angles. The graduate applies trigonometric ratios and triangle formulas. Trigonometric ratios and triangle formulas to model and solve real-life problems. Identify characteristics of angles, compute angular measurements in both radians and degrees, use properties of arcs to model and solve real-life problems, apply the law of sines or the law of cosines to solve oblique triangles, apply right triangle side ratios to evaluate the 6 trigonometric functions, use right angle trigonometry to model and solve real-life problems. Use reference angles to find. All right, so things I probably we want to memorize, right? There's all kinds of trigonometric functions, and you can move them all around in different kinds of ways. But the basics here, things to memorize. I want to absolutely know, like my new multiplication tables, right? Let's see if this copies and pastes well. Yep, good. The law of sines. And the law of cosines. Okay? Now, apply right angle side ratios to evaluate the 6. Okay, I'm going to want to know the 6 trigonometric functions. Right. Use right angle trigonometry to model and solve. Use reference angles to find. Okay, the law of sines and the law of cosines are the 6 trigonometric functions. Fine. That's in terms of the trigonometry of angles. That's a competency. Okay, that's the first competency there. Need to like really know and apply. Now, the trigonometry of real numbers. Analyze the inverse sine or inverse cosine functions. Evaluate the compositions of trigonometric functions with inverse trigonometric functions. Apply trigonometric functions to model periodic phenomena. Apply apply a unit circle to find the values of trigonometric functions. Okay. So half tangent, cotangent, secant, and cosecant functions. All right, so in the competency 2 here, we're going to want to really know all of these things about the unit circle mastery. Go over there. There's some really good like YouTube videos about memorizing different things there. Trigonometry of real numbers here. Okay. Good. Now, analytic trigonometry. The graduate provides trigonometric identities and solves trigonometric equations. Use algebraic, quadratic, and inverse trigonometric function methods to solve trigonometric equations. Use trigonometric formulas to solve trigonometric problems. Apply the fundamental trigonometric identities. Dun, dun, dun. That's something I want to memorize. The fundamental trigonometric identities in evaluating and simplifying trigonometric functions. Analytical trigonometry. Like the thing is, that's one of the things I didn't really like systematically do in the previous times I looked at this stuff. Is like really systematically memorize some of the core backbone material of trigonometry. I would kind of like remember it, but I wouldn't like super memorize it. So this is going to be time to super memorize it. Analytic trigonometry. Weird. Okay. Trigonometry. There we go. The fundamental trigonometric identities. All right. Complex numbers. The graduate applies various representations of complex numbers to solve problems. Convert the rectangle form to the polar form of complex numbers. Conduct multiplication and division within complex numbers in polar form. Use the theorem to find powers and roots. Okay, so I'm gonna want to memorize this theorem. To find powers and roots of complex numbers. Recognize the properties of complex numbers, including the relationship between complex imaginary and real numbers. Conduct addition, subtraction, multiplication, and division of complex numbers in rectangular form. All right, fine. So, complex numbers. Complex. And this is like complex numbers in trig. Right? It's not just like regular algebraic complex numbers. All right, so we're going to want to memorize Moivres Theorem. That's DeMoivre. I'm going to have to learn to pronounce that better still. DeMoivre. DeMoivre. Let me review that again. Pronounce. You know what? These things can be kind of annoying, like these computer voices. What if I just like looked at DeMoivre's theorem? Somebody talking about it, maybe. Skip ad. Thank you. DeMoivre's theorem. DeMoivre's theorem. I don't know. I don't know if I totally trust that pronunciation. Moivres theorem. Moivres theorem. Moiv. But I did get the Moiv idea instead of like being stuck on my move idea. Moivre. DeMoivre's theorem. That actually might be right. DeMoivre's theorem. Using DeMoivre's theorem. Okay. Very good. Now, moving on. DeMoivre's theorem. I think I'm satisfied. DeMoivre. Of course, I mean, he's pronouncing it the way it's spelled. If we're going to pronounce the O-I, oi, DeMoivre's theorem. All right. And then if I look at the computer voice again, amounts. Ugh, the Moivres theorem. This is cringy. I can't stand that one. All right. What about this one? What? Totally different. See, I'm worried that people are not taking the time to really learn how to pronounce this. So this is actually somebody submitted this. Somebody who claims to be a librarian of some kind. Well, yeah, because this is, yeah, okay. Let's see here. Um, right. Mm, wow, that's a pretty awesome theorem there. That you can take away the power, you still end up with a complex number, but whatever. But where is the pronunciation of this? Okay, French pronunciation. So it's a French pronunciation. I'm not gonna look at the International Phonetic Alphabet here. French pronunciation, huh? Abraham. There's the dude. Abraham Day somebody. Can't be as simple as Moivre. Can't be that simple. Not be that simple. DeMoivre's theorem. DeMoivre's theorem. Moivre's. Because not even. That sounds like French, not pronouncing all of the things at the end. I don't hear the R at all. I don't hear the R at all. Moivre's theorem. Moivre's theorem. Where are they getting these pronunciations? I don't believe them. I don't believe them at all. Like, this is ridiculous. I believe that guy. I have to investigate further later. Where? Yeah, Frovo. Frovo. Moivres theorem. DeMoivres theorem. DeMoivres theorem. All right, we'll save that a bit. And then yeah. Over here in the IPA, the International Phonetic Alphabet. So that's Abraham. Moivre. Yeah, that's looking like what this guy is saying. What is this X upside down R thing here? Okay. Guttural R? Regarder? Garter? Guttural R. In the front or Scottish English law. Good voice. Loch. Something. Ugh. I who? Garter? Garter. Garter. Regarder. It doesn't seem. I don't know. Moivre. But definitely getting the W to A thing there. Because W is W, right? Yeah. Yeah. So this idea of the W sound. Yes. Yes. DeMoivre's theorem. DeMoivre's theorem. DeMoivre's theorem. Do French pronounce RE at the end of words? They drop a lot of sounds at the end of words. DeMoivre's. DeMoivre or DeMoivre? DeMoivre, I doubt it's DeMoivre. Moivre. They don't even have here in the Wikipedia, they don't even have a vowel after that. So DeMoivre's theory. DeMoivre's theory? DeMoivre? Or DeMoivre's theory. DeMoivre's theory. DeMoivre's theorem or DeMoivre's theorem? They probably are dropping that R sound. Well, okay. Looks like the word movie almost. Right? Doesn't it look like the word movie? Almost, if you move the I over there, the I is before the V. DeMoivre's theory. DeMoivre's theory. Spelling it right? Yeah. Okay. Aha! Right? And this is that site. This is Frovo again. And this is a French person saying it. DeMoivre. So the ending here, I'm hearing it as almost like an at the end. DeMoivre. DeMoivre. All right. All right. So we're not really doing that R at the end. DeMoivre. DeMoivre's theory. I'll make it sound more and more Italian, but okay. DeMoivre's theory. All right. So these, I am saving these. All right. Um, so we have here pronunciation. Oh, French name, American librarian, French name in French. Okay, that's it. It's clearly speaking with a French accent there. Now we have over here this. Right. Boom. Save those pronunciation things there. That was a good combination. Moivres theory. DeMoivre's theorem. DeMoivre's theory. DeMoivre's theorem. DeMoivre's theorem. But I'm not gonna speak in a different accent. DeMoivre's DeMoivre. I don't want to sound like I'm trying to make a different accent. Well, but I still want to pronounce it the right way. DeMoivre's theorem. Like I can imitate this American librarian guy. DeMoivre's theorem. That's probably DeMoivre's theorem. That's probably a good like American accent, decent pronunciation of the name. All right. Whew. Okay. I was a little worried about that. Right. As we want to teach this stuff. We don't want to be like teaching it the wrong way, pronouncing it wrong to everybody. So that's just not acceptable. Let's see. Now, DeMoivre's theorem to find the roots of complex numbers. Recognize the properties of complex numbers, including the relationship between complex imaginary and real numbers. Conduct addition. So now, the next one, 5. Systems of equations and inequalities. The graduate uses systems of equations, systems of inequalities, and matrices to model and solve real-life problems. Convert between systems of equations and their matrix representations. Solve systems of linear equations by using matrix methods. Right, so we really want to memorize some of those matrix methods better. Model real-world data using systems of equations. Solve systems of linear equations. Okay. All right. Systems of equations and inequalities. Of equations and inequalities. Not things things I want to memorize. Memorize. There we go. Memorization priorities. Memorization priorities. Okay, there we go. Matrix methods. Okay, model real-world data using systems of equations. Matrix. Okay, now the last competency here, number 6. The graduate explores arithmetic and geometric sequences, not arithmetic sequences. Arithmetic sequences. Are there Arithmetic sequences. Yeah, I guess that's the only way. There's not an adjective alternative pronunciation of arithmetic. Anyway, the graduate explores arithmetic sequences and geometric sequences and uses them to model and solve real-life problems. Use sequence, factorial, and summation notation to solve problems. Okay. Determine partial sums or the nth term. Use arithmetic sequences to model and solve real-life problems. Determine partial sums and the nth terms in geometric sequences. Use geometric sequences to model and solve real-life problems. Okay, so notation. There's different kinds of notation. You need to be familiar with these notations for sequences. Sequence, factorial, and summation notation. 3 kinds of notation. All right, preparation and self-evaluation. So on and so forth. Okay, I can look at that a little bit later. We can end this video right now on discovering our memorization or anticipating our memorization priorities. So I will pull up this and stop.